Okay, carrying on with our examples of horizontal translations. Previously we saw that when we replaced x with x plus 2 inside the function notation brackets, we actually moved the graph 2 to the left. Now let's look at another example. Now we're replacing x with x minus 2. Given y is equal to f of x as defined above, graph y is equal to f of x minus 2. So again, when x is negative 4, now we don't actually want to look up f of negative 4, we need to plug negative 4 in for x there. So f of x minus 2 becomes f of negative 4 minus 2 is equal to f of negative 6. And looking at either the graph or looking at the table, we realize that there is no f of negative 6 because the graph doesn't go that far. So there's not going to be any of this new graph at x when x is equal to negative 4. So let's carry on though and see what happens. When x is negative 2, f of x minus 2 becomes f of negative 2 minus 2 is equal to f of negative 4, and that's going to be equal to 0, looking it up on the table above. When x is 0, f of x minus 2 is f of 0 minus 2. So f of negative 2 and f of negative 2 from the graph above is negative 4. When x is 2, we get f of 2 minus 2, that's f of 0, and f of 0 from the graph is 0, or from the table is 0. When x is 4, again we subtract 2 from it, as indicated there, f of 2, and looking that up above is 2. And now, when x is 6, we get f of 6 minus 2 equals f of 4, and f of 4 is equal to 0 from the table above. Now, we didn't have an x value of 6 in the original function, but we will now, because 6 minus 2 is equal to 4, and f of 4 is something that we can evaluate. Okay, so taking a look at what's happening here, if we plot all of our functions, all of our points, we've got the point negative 2, 0, the point 0, negative 4, the point 2, 0, the point 4, 2, and the point 6, 0, just reading these all off of the table of values. And again, if you'll excuse my lines, I'll try and draw the new function, which is going to look something like that. And so you can see that whereas in the original graph, I'm going to go back one now, we had moved, in the question before, we'd moved left 2. Now, in the one that we've just done, we've actually moved right 2. So replacing x with x minus 2 has now given us a horizontal translation to right. Okay, so let's go back and compare the two again. When we looked at the one before, replacing x with x plus 2 had moved the graph to left. Replacing x with x minus 2 had moved the graph to right. So that's kind of what I mean when I say it's a bit counterintuitive. Let's try and express that more generally. So horizontal translations happen when you replace x with x minus d. And we put the minus there because that makes moving to the right sort of the convention. So when you replace x with x minus d, you move the graph right by d units. So this, y is equal to x minus 3 all squared, would be a parabola moved to the right by 3. And you're probably familiar with that from learning about parabolas and quadratics last year. However, if d is negative, so imagine this is, imagine you put negative 5 in here. Well, negative 5 is positive 5. Okay, so x plus 5 is actually x minus minus 5, or minus negative 5. And that's going to move the graph left. So this is actually moving the graph 5 to the left. And you might be familiar with that from your previous course as well. Okay, so horizontal translations occur when you replace x with x minus or x plus something, and they move in the opposite direction than you might initially think. We're going to continue by looking at horizontal stretches.